Warm welcome back to the Information Security Stack together with me, Daniel Gustafsson, and Kim Hindart.
Hubba.
We have a purpose with this podcast, not only to talk about events and recent events and articles and so on. We also have an ambition to teach a little bit and spread the gospel of our knowledge, our enormous depth in knowledge, Kim. So we have a session called What Is? And today we're going to talk about what is a cloud in general, actually, because we do think that cloud unfortunately became a bit of a buzzword, and then we have something called infrastructure as a service and platform as a service and software as a service, and not everyone can actually exactly define what the differences are. So should we start with the infrastructure as a service bit, the IaaS bits?
Yeah, or should we perhaps just start with the different type of clouds?
Fair enough. Let's do that then.
Let's start with not all clouds are equal. And just to be clear, cloud, as I got it described by a government authority as late as last week, cloud doesn't have any persistent hardware. You don't have any storage in the cloud. You just use things, and then when we stop use it, it's gone. Surely that's how cloud works.
No, it isn't. And that actually brings me to a story that I got about in 2009. It's quite a few years back, but I got a similar description from a CIO at the time at a very big corporation in Europe, who described the cloud as, if you think about big tower masts like it is on in a mobile network, and between those enormous giant masts there were just data flowing randomly. It didn't exist because she had been given the explanation that in a cloud you don't have any servers. And true, the company in itself does not have any servers. At least not physical ones. They had virtual ones, but she was very upset that they had sent her an invoice for servers in a cloud, which that provider had very integrated explained that she wouldn't have any servers at all in a cloud. But in a cloud there are servers. There's an infrastructure behind it. So even though if you use a cloud service, no matter which cloud service you use, and yes, there are multiple cloud services out there, thousands of them. So even if you talk to a specific vendor who might claim that they are the only cloud in the world, they're lying. There are multiple clouds in the world, and all of them have infrastructure in the back end. Hence, that's what we do.
But the problem is a lot of people tend to say we have infrastructure connected to the internet. Now that's a cloud. No. That's also not a cloud. But let's go down to the nitty basics. If you have a digital application, any type of application, you need storage, you need CPU power, so RAM and CPU cores, and you might need networking. That depends on the application, but let's get real. No useful application today usually persists long without networking. So if you build any type of web-based application, networking is a demand. So, but these three things, and these three things only, are still the things that any digital application needs. In some sense, but CPU, and I include the GPU there as well, but computing, you call it compute, you call it storage, you call it networking.
Yep.
These three things are a necessity for any type of digital application. If you can buy these three things as a service, now you're talking cloud. So we like ISO definitions. I really like the ISO definitions. Why, you might think? Yeah, because it's easier if you have a set of global definitions defined by a standardization organ. It's easier to say, why don't we follow the international standard of what is a cloud? Then you have to argue why your definition should persist above the set international standard. But anyway, and the ISO certification that you should look at, it's 17788. So
Yep.
ISO 17788 describes what is actually a cloud. We will link it in the description, of course. But yes, and that's the nice part with this is actually it's for free as well. So you can just download it and see. And then you have different types of cloud. You have public clouds. These clouds, what's public cloud then, Danny?
Well, that's for anyone at any time to get access to. All you need essentially is a computer and an internet link, and you go to a public cloud provider. Could be Amazon AWS, could be City Cloud, it could be Microsoft Azure, or any type of provider which have a portal, web portal, in which you can create an account. Probably with your own credit card, you will sign up. And essentially, when the sign up is done, you can start launch services in that public cloud. Hence the word public. It is for anyone at any time. And all I need is a computer and an internet link.
So the important part, it's shared between many.
Yes.
That's the nice part to remember. And then you have the opposites called private cloud.
And that's when it's only for me. The infrastructure behind it is only solely devoted to me.
Remember here, it's still a cloud because the definition of a cloud is that you should be able to consume infrastructure with a pay-as-you-go model. So that's the part we're talking. So we have, in one end, we have the public cloud open for anyone. We have the private cloud open only for me, dedicated infrastructure only for me. In between, we have what's called community clouds.
Yes.
We provide that, the City Network, but can you explain what we mean with a community cloud?
Well, that's a cloud that is defined and dedicated to a specific type of customer with a specific type of regulatory demand, for instance. The customers in that infrastructure share the same type of demands in terms of compliance, in terms of security, or whatever it might be. So a community cloud could be defined as a group cloud for a specific industry, for instance, like bank and finance or car industry and something like that.
So yeah, so you can think of a public cloud as a huge student corridor or sleeping venue.
Yes, dormitory.
Every people sleep together in a big, huge room. That's the public cloud. Then you have the community cloud. That's more an apartment complex.
Yep.
Each vendor you have your own apartments, but you have neighbors also that share a house.
Yeah, gated community, we could call it.
Yeah, and the private cloud is, of course, you have your own house all to yourself.
Yep.
So that's, and as you can imagine, there's less and less opportunity for noisy neighbors to disturb you.
Exactly.
That's the part. And then we have what's called hybrid cloud.
And that's when you use either or combined. So you might have a private cloud, which is yours, which is your base cloud, so to speak, where you have your majority of your information, but you could use the public cloud for some instances like public services or web interfaces, whatever it might be. And then you can combine the two, hence a hybrid, which is very beneficial.
So when people think of multi-cloud and when people think of hybrid cloud, they usually think of multi-vendor. That's also excellent opportunity, but that's not the only thing. The very, very best efficiency you can get with the cloud would, of course, be a combination of both public cloud, community cloud, and private cloud in different areas. So they're good as different things.
But you just mentioned something quite interesting there, Kim. So if I want to have my best redundancy in my own application, shouldn't I be able to use like you said, multi-vendors, multiple vendors at the same time. Let's say I have a need to be in Asia and I have a need to be in the US and Europe. But my provider in Europe, for instance, might not be able to provide clouds in Asia or US. Shouldn't I be able to combine those clouds?
Exactly. So having a multi-vendor strategy is excellent.
Is that feasible at all times?
Absolutely. If you don't do a lock-in, this is what the big hyperscalers tend to want to offer. We are everywhere, so we are the only cloud you will need. If you ignore the features that are strictly dedicated to only one specific vendor and use open source features, there's awesome, excellent, lots and lots of open features out there that will remain open. The huge majority of internet is based on open source technologies. So if you use those and keep to those, you have the very, very excellent opportunity of being fully multi-cloud, multi-vendor, hybrid cloud, all you want. And then you don't have a specific lock-in to any specific vendor. And this is an excellent part today with the technology. Because the technology part of a cloud is based on virtualization. You should not be concerned about hardware.
Nope.
You represent your old physical hardware like servers, firewalls, switches, networking equipment are represented as digital files, virtual objects, and when run through a hypervisor, they all of a sudden now become a digital representation, a virtual object of a physical server. They behave in the same manner. So the hypervisors make this digital file act as if it were a server with specific programs installed on it. And so virtualization is a technology that is necessity, that is the baseline for providing clouds. But it's not a cloud in itself. Just by having a virtualized server, it's not a cloud. The definition for it in order to be a cloud is that should have broad network access, be under a self-control, so you should be able to regulate your consumption up and down as you please. And you should be able to do this from a self-service point. You should be able to build your entire virtual data center or your virtual technology stack from the bottom up directly. So when you want to launch an application, you should be able to just go to the cloud, put in your application code, launch, and it should be all launched through your single code. This can be done in different layers, as we're going to talk about software as a service, platform as a service, and infrastructure as a service. But what they all have in common is that you can, through a single sort of interface, launch your entire application directly without the need for any physical hardware at all. And that's the whole idea with a cloud. Everything is virtual, and if everything is virtual, you can handle everything as code. And now you can digitalize in a lot faster pace, because it's a lot faster to get new servers. If you go to City Cloud, it takes a few seconds, then you have 3 new servers. If you physically need to go out and buy 3 new servers, it takes a lot longer time. So,
or if you have to order 3 servers from your IT department as well.
So this is how you can perform change a lot faster. That's the whole idea. Now, former CEO of IBM, Virginia Rometty, said something nice when they purchased Red Hat. She said, cloud, it's going to cost 3 times as much, but be 10 times as fast.
Yes.
This has not been...
No.
this has not been the message all the time. So from a marketing point, we made a big failure with cloud. I dare say this is the vendor's biggest failure. We included was part of this, and that's the biggest failure.
For sure. Because what was our initial message?
Cloud is cheaper.
Yes, you're gonna save money in the cloud.
That's
not necessarily true. Not necessarily true. Could, but in the long run, it's probably gonna be more expensive.
Yeah, and just prepare yourself. It's going to be more expensive because you are going to be more digital. You're going to do the digital transformation. So we're going to be a lot more digital. That's just life. If we're back 20 years ago, you could run a business without having anything else than your number in a phone book.
Yep.
Where's the phone book today?
It's in your phone.
Yeah, so you need to have an internet presence, or you really don't exist. So that's so. Anyway, this has changed a lot, but what I think the most important part is, of course, cloud can be cheaper in certain situations, like we talked about the MultiCloud. If you have your test environments, it's a lot cheaper today to replicate and deploy a full copy of exact copy of your production environment. Set that up. This is, of course, that you do this automated. Otherwise, it's no point. But you set that up, do the tests you want to test, and then take that down. And you only pay then for the resources you consume during the time you need it. So if you imagine test environments is excellent to have in public clouds. Then you might want to have things that have more sensitive data in your production environment. Then community clouds and private clouds are better suited for that. So you have more control. But test environments, that's excellent thing to have in the public cloud, and only consume when you need and then take it away. So this demands, of course, that clouds should be scalable. You should have the possibility to consume resources when you need it and then take them away when you don't need it. So you only pay for the time that you use the resources. So this is also an important part in a cloud. And so for testing purposes, that's great. And then you can save a lot because it's a lot more expensive if your test environment are going to be an exact copy of your production environment. If your test environment is not an exact copy of your production environment, you will always run into the problems that you face when tests done in the test environment still fail in production. But if you have an exact copy of your production environment, then you can eliminate that. But that would be crazy expensive if we're talking you having your own hardware. Imagine if I have an application that uses 20 servers. If I were to go and buy a new test environment every time I wanted to
it wouldn't be fun. It wouldn't be feasible.
I would need to have 20 new servers all the time, and that wouldn't be possible. All of a sudden in a cloud, that's possible. So there you can save money. But that demands that you have a high level automation. So just because you are going cloud doesn't mean you will become more efficient.
No, for sure. And especially if you just try to implement an application as is into a cloud, you're not going to gain anything. You're going to have to rebuild it so it actually can draw the benefits of a cloud to be automated, just like you explained. So essentially, from a cost perspective, your production environment will probably not be cheaper. It will probably be more expensive, but it will be faster if you do it correctly. And the change process will be a heck of a lot faster, which will be the actual benefit of you using a cloud for your production environment. But for test and for stage environments, it's a massive change or save in money, essentially. Because that's as Kim just explained, that's the pure benefit of just launching, removing, not use it anymore. And a physical server, you can't just remove it because it's going to be there. It's going to continue to cost. So that's the actual benefit. But remember that a cloud is still someone else's servers. You will not, there will still be hardware failures in a cloud. There will still be downtime in a cloud. That's still a possibility because it's actually physical service in the back end. And do not put all your eggs in one basket either. Make sure you share the load between servers and preferably between deployment zones as well, availability zones as well. So you just don't just use one availability zone with one server, because then the benefit of a cloud is gone as well. So for anyone out there who actually thinks that I can put everything in one server and it will never disappear in a cloud, I have something to tell you. It will disappear in a cloud eventually, because a cloud can actually fail and go down. So make sure you have a redundancy and you have a proper failover procedure, even though you're using cloud services. Then there are different technologies which you can use. You can use VMs, as Kim has talked a lot about. You can use containers, which is really popular these days. So that's a different type of spreading your application and different spreading your loads between the data centers and availability zones. So there are ways to do it, and we can go into details regarding those things in the future. But make sure to understand that you're not fail-safe in a cloud just because you put it on one server in a cloud. That's not true.
No, it's always related to a specific hardware. So this is, of course, as you might understand, a thing that you need to build your services with this in mind. That's the whole idea.
Yes.
You need to build your services with automated deployment, automated scaling in mind from the start. So what would you say? I have a huge mainframe with a mainframe application. Surely I can just take that mainframe and poof to the cloud. And now I'm more efficient, more digital.
No. This is a present from me to you listening. If you have an old legacy system, leave it be. Let it die in the environment and the service that is existing on currently. Don't mess with it. You will draw very little to no benefit of putting that type of service into a cloud, because it's not built for a cloud automation process. However, all the new things that you're trying to put out there and build and make available to your users or your customers, that should be deployed in a cloud, because then you have the chance to build it for a cloud purpose from the beginning. Old mainframe systems, leave them alone. Let them die a slow death in their own basement. Don't even go in there. That's a rabbit hole for sure.
Yeah. The sad part is, and I know a lot of you is wishing for a unicorn right now. But there are no unicorns, sorry to say. You will, in order for you to be able to change faster, to be able to have a faster pace of change, you will need to rebuild a lot of the functionality of your legacy systems in the cloud.
Yep.
The nice part is you can use the same functionality and the same data as you have in your mainframes. But if you build them in an application stack that's cloud-based from the start, you will have a lot more opportunity to do faster and quicker changes than if you keep them on a mainframe. So there's a big point, but you cannot just take the mainframe itself and push it to the cloud and think now you are
you're cloud
more
ready.
efficient. That won't work. So
no.
Sorry to say that. It's always better to roll up your sleeves and rebuild the functionality you need. So yeah, we have discussed this plenty, that if you have lots of trees or you have this huge pile of dishes that you need to clean, one at a time. That's what you need.
Yeah.
Roll up your sleeves and do one at a time.
Yeah, exactly. You have to win the long war here. The short term battles are not. No, you have to win the long war is what you want to win here. It's going to take time.
So should we talk a bit about the different types of services provided as well? We have three big ones. We have software as a service, platform as a service, and infrastructure as a service. Now, you might hear a lot of popular database as a service, firewalling as a service, pretty much anything as a service today. I even have food as a service today. I can order, but still, from a cloud perspective, the big three parts that usually gathers and can collect and be a gathering point of everything else is software, platform, and infrastructure service. So what's the difference between these?
Well, let's start from the ground up then. The infrastructure is essentially what we have talked about to a long extent already. It's the back end, it's the infrastructure, it's actually the physical service, the network, making sure that you have something to build your applications on. So that's the back end, your data center essentially. That's the infrastructure as a service. And if you purchase an infrastructure as a service from any type of provider that provides a type of a cloud, you will be given a bare naked infrastructure which you would then have to build virtually everything on top of it. So you don't have to worry about the backend servers, you don't have to worry about internet connections and so on. That's fixed for you, but you're going to have to build your virtual setup in terms of your virtual servers, your virtual network, and everything on top of it. So that's the infrastructure bit. So essentially that is replacing your data center, essentially. The platform part is when you take a step up in the stack. Those providers, they provide a service on top of it. Microsoft 365, for instance, is a platform as a service. They provide you a platform of features which you then can use. So you have to only worry about the actual distribution of the users and how you're going to use your SharePoint or whatever it might be. So the actual platform is already there. You don't have to worry about the back end. You don't have to worry about the data center. You don't have to worry about the software containing the platform which you're using. So that gives you the opportunity to then just launch your applications into that specific platform, for instance. But it still gives you you still have to maintain those applications.
And you still have to build the application itself.
Yes.
That's the important part. Yeah.
Yes. And then we have the third one, which is a software as a service. And that's the top end of the stack, meaning those providers have built everything to the user level, so to speak. So let's say Spotify, for instance. That's a software as a service. I just log in, I register an account, I click on the music link that I want to listen to, and hey, presto, it works. That's a software as a service, meaning I'm just a user in a platform provided by a vendor. So I don't have to worry about anything. I just have to worry about using the actual features, which is very convenient. But I have no control of the backend, and I have no control of the platform, and I have no control of the actual application. I'm just happy that someone else is developing everything else for me, essentially. So those are the three layers that we are normally talking about in terms of cloud. And everything else is just gravy on top of it, essentially.
And as you can imagine, if you're used to having the entire technology stack, all from the application of the end user to the power socket that you put your hardware into. Now, if you're going cloud, you will start to share different parts of it. And this is essentially, where do you end and where do you start your sharing? And you will have to split the technology stack between a vendor and yourself.
Yep.
But yeah, why should you split this? Surely it should be more efficient to run everything yourself.
Well, it depends on how much work legwork you want to put in, I guess. And also, there's a great benefit of using multiple providers as well for use different services. But it really comes down to how much work do you want to put in? What do you want to be responsible for? What should be your purpose of your business? Let's say you are working with, let's say you're a construction company. I would recommend you focusing 98% of your time on being a good constructor and building houses. And the IT department should be, the IT bits should be as easy to use as possible. Here's where cloud services comes in. Or you can say, I want to develop everything myself. Okay, but then that construction company is going to become an IT company really fast. And you're going to have 150 people working in the IT department rather than being builders.
And if you compare it to the sense, if you're a construction company, you will surely buy your machinery, your heavy machinery, especially from ready-made vendors.
Yes.
You won't build them yourself.
No.
No construction company today build their mobile crane directly from scratch everything themselves.
No.
They usually buy it. No construction company designs their own engine for the caterpillars. They buy that.
Yeah.
So
very few will say very few will say our power tools are too bad. I'm gonna build my own. No.
Yeah.
That's not gonna happen.
It's still a necessity in a construction company, but you don't build them, you buy them ready from a vendor. The same can be done with IT. Unfortunately, IT parts usually have not been built in that sense.
No.
What parts should you build yourself then?
Well, from an application perspective, I would say the end user experience could probably be something you should be responsible for.
I usually say that things that are commodity things, like for instance, an email account. Email works as very standardized set account. One email account can work from another. There's a reason why email works with plenty of different vendors, and they can still email each other. We don't need to be all in Office 365 to email each other.
Yep.
We can still do it. So that's the opposite of this is, of course, the different chat applications like Signal. We have Zoom and Teams. You can't Zoom to Teams and Teams to Zoom.
No, unfortunately.
So that's the tricky part. So, but you can still email between. So these commodity things are excellent to buy as a service today. So you need to have build the underlying machinery to sustain them. But the next part is when you want to have a digital meeting with your customers. This digital meeting makes a whole lot of sense to control yourself and design yourself.
Yeah.
So the digital meeting we have with the customers is something I think for a long time we will design our own applications.
Yeah, I think so as well. And that's time well spent as well.
So
rather than just doing things that is not important for you.
Because that's what makes you unique. Your meeting with your customers.
Yeah, exactly. So anyway, that is cloud in a nutshell.
Until next.
Have a great week, everyone. Take care.